Hello, everyone. Welcome. Thank you for taking the time out of your day to join us for today's webinar. We're really excited to have the team here from Advanced Architectural Products. We have Kevin and Jose, and then Christy, who's helping out in the background as well. And then my name's Kayla. I'm here representing the Acelab team. And so while we're letting everyone trickle in, I want to quickly show you all where you can learn more about advanced architectural products, Z-girt, all that good stuff on their brand page here. So here we have the page. Can you guys see my screen?
Yes.
Kevin? Okay, perfect. All right, so here we are on the page. We've got some basic information for you to check out. We've got Jose's contact information here as well if you'd like to get in touch with him. A few value propositions as well as many products for you to explore. So we encourage you to check out this page, click into any one of these products if you'd like to learn more about it. You are also welcome to save it to your firm library for future reference. So definitely check this out when you get the chance. I'll drop a link in the chat. We've also got some excellent case studies for you here. So a few other items to go over before I pass it over. We will be doing Q&A towards the end of the presentation. So if at any point you have a question, you could just go ahead and drop it in the Q&A box that's at the bottom of your screen. We also will be doing a poll during the presentation, so you'll see that pop up. And if you're interested in getting more information from today's presenters afterwards, you can fill that poll form out. Um, Lastly, today is an AIA accredited presentation. So we collected your numbers upon registration. If you're concerned that we didn't get your AIA number, I will also be dropping a form in the chat. So you're welcome to use that form to ensure that you get credit for today's presentation. So yeah, that's everything on my end. I'll go ahead and pass it over to Kevin and Jose.
Awesome. Thank you, Kayla, and welcome everybody. Good afternoon. Thank you for joining us for this webinar in collaboration with Acelab. My name is Jose Carrasco. I'm here with my colleague Kevin Mlutkowski, and we'll be chatting a bit today about selecting continuous insulation Z-girts to meet today's building codes. Just a bit about Advanced Architectural Products before we get started here. We are the manufacturers and engineers of continuous insulation and building enclosure systems. So Z-girt CMH and Z-girt steel, those are our composite metal hybrid and steel-based continuous insulation systems. And then Smart CI is our building enclosure system, which works with the Z-girt CMH product, coupled with custom routed rigid insulation as well to give you that full building enclosure. As Kayla mentioned, this is an AIA accredited course, so here's just some additional information for you here. And then lastly, we have our learning objectives. So today we'll start off with sort of just some fundamental principles of building envelopes. We'll start with some definitions and kind of give you a better sense of how different materials work together to form a building envelope. From there, we'll look at some various continuous insulation Z-girt systems on the market, really looking at composite metal hybrid, perforated thermal metal, fiber reinforced polymers, and our traditional steel continuous insulation Z-girts. We'll also talk a bit about today's modern building codes and how sort of energy conservation plays a role in the way we uh, meet today's building codes and standards. And then lastly, we hope that you'll leave here this afternoon with a better sense of how to select the continuous insulation Z-girt that best fits your project requirements. So without further ado, let's get started. Well, you'll hear the term Z-girt a lot today, so we thought it would be best to start off with just a simple definition of what is a continuous insulation Z-girt. So what we have on screen here is an image of a Z-girt itself. So this is a subframing component that's installed on the exterior of a building, and it really works to both hold your continuous insulation in place as well as give you an attachment point for your cladding. So as you can see from looking at that side profile there on screen, you see how it forms that Z shape there, giving you two attachment points, one attaching to the building substrate, and then the other front flange giving you a place to attach the cladding, with that middle cross section there forming serving as the spot that holds your continuous insulation. A Z-girt is typically one of the last components installed on a building. So typically you'll see this is the component that really sits right behind the cladding or the outside structure that you see from a building. This here just gives you a sense of what continuous insulation Z-girts look like in practice. So as you can see on screen there, those green lines that you see are those Z-girts that we saw on the previous slide. On the top there, you can see a horizontal versus a vertical installation. You can see that it's compatible with different types of insulation. So Z-girts are compatible with mineral wool, spray foam, rigid board insulation of any kind, and then as well as compatibility with various types of cladding. So that bottom right image there, you can see there's several different types of cladding that are being used and incorporated with those Z-girts there. Some additional definitions. So you'll also hear the term building envelope a lot today. And when we talk about building envelope, we're really talking about the systems and materials that really work together to separate and form a barrier between the interior and exterior environment of a building. Typically, your building envelope is going to consist of four main systems. It's going to be continuous insulation, an air barrier system of some kind, a weather-resistant barrier, and then finally your cladding. And all of these systems are really going to work to monitor four things, and that's going to be heat, weather, structure, and fire. So again, when thinking about a continuous insulation Z-girt to select, you really want to choose a system that has a well-designed envelope and really provides a system that's going to eliminate any potential failures in the future, as well as greatly increase the performance of the building from a thermal perspective. Taking a building envelope one step further is a building enclosure system. So first and foremost, a building envelope and building enclosure, they should really first work to identify and make sure that they support any structural loads that are required for that building. Um, so in terms of a building enclosure system, not only are we managing those four aspects of a building envelope, heat, weather, structure, and fire, but a building enclosure system also manages the movement of air and moisture. So while you may be solving many problems by installing a building envelope on your project, you really don't have that full air and watertight seal until you install a building enclosure system. And then here we have a definition from ASHRAE of continuous insulation. So it's insulation that is continuous across all structural members without thermal bridges other than fasteners and service openings. It is installed on the interior or exterior and is integral in any opaque surface of the building envelope. So really the main differentiator here is insulation that's not continuous is typically inside of the wall cavity. What makes continuous insulation different is it's either fully on the interior or exterior of that wall, not in between the two cavities. And as the name suggests, when you implement insulation in that manner, you get that continuous sort of membrane and protection around your entire building. Important here to note, you'll hear us talk a bit about thermal bridging today as well. And even though the code does allow fasteners in order to meet the definition of continuous insulation, keep in mind that each of those fasteners do create a tiny small thermal bridge because they are a conductive material. So to the extent that you can, when looking at various Z-girt and continuous insulation systems, really try to choose one that minimizes and eliminates as much of those fasteners as possible. I talked a bit about thermal bridge. Here we have a very simple image of what a thermal bridge is, and that's essentially when there's a temperature, when there's some sort of transfer of energy, whether it's hot or cold, that penetrates the exterior from the exterior environment to the interior. So what we have here is, assuming it's a cold day outside, you can see there's some frost on the roof there. And you can see the sort of the vertical lines both on the roof and on the wall there. That's an example of a thermal bridge in action happening there. There's essentially heat losses escaping from that building there. This is important because the thermal bridge is really the number one killer of thermal efficiency in your insulation system. So keep that in mind again when selecting a continuous insulation Z-girt system. You're investing a ton of money up front in the insulation that you're buying for that project, and you really want to make sure by eliminating thermal bridging that you are getting the maximum efficiency that you're expecting out of that insulation product. And then lastly, we have this idea of the perfect wall. So when you're designing or constructing a building envelope, you want to keep this idea of a perfect wall in mind. And what this really does is protect the innermost structure at all costs. So a few slides ago, we had talked about those four different layers that separate the interior from the exterior. This is sort of a visual representation of what that looks like there. So your first layer of defense will be your cladding. Um, Anything that perhaps makes its way beyond that will run into the control layers. That's where you have your Z-girts and your continuous insulation, as well as your other barriers. And again, this is all working to manage and mitigate any moisture, air, or thermal control penetrating the structure of the building itself. With that, I will turn it over to Kevin.
Great, thanks, Jose. I'll spend some time now talking about some different trends and activities that we're seeing in the marketplace, specifically regarding both mandatory codes and voluntary codes, and sort of what we're seeing from a continuous installation perspective. We will talk about sort of the impact of ASHRAE 90.1, the International Energy Conservation Code, the International Building Code, as well as some of the voluntary certification programs, including Passive House, LEED, and the Green Globes program. But first, starting about with the mandatory code requirements, there's been a lot in ASHRAE 90.1 that talked about thermal bridging and continuous insulation systems. So you can see on the left of that chart sort of the progression of years from 2001 up until the current 2022 code. And sort of the content that's in there to acknowledge continuous insulation, as well as driving demand for its use in creating more energy efficient buildings. Want to specifically call attention to the 2013 edition of ASHRAE 90.1. And that's the first time that there was a specific requirement added for continuous insulation to meet the R value and U value standards, thereby creating buildings that are much more energy efficient and having that in code language so that it can really drive the development of more energy efficient structures. And then again, 2022, we're hearing things about the 25 edition as well that will further push for higher continuous insulation. You see a similar trend on the International Energy Conservation Code, the IECC. Roof insulation, roof continuous insulation has been a requirement for the past many years. You could see the R30 since at least 2018, but you can see a marked increase in the requirements for higher performing wall continuous insulation systems as well. All wall insulation systems overall, both cavity insulation and continuous insulation. You could see the increase from 2018 through 2021. In 2021, continuous insulation was actually a requirement. You had a couple different compliance paths, but it is a requirement in 2021. In 2024, adding additional options, all of which have higher R value performance requirements, but additional compliance paths. With the highest being the R20 continuous insulation you could see there in the 24 edition of the code. And then, of course, everything that's in the International Energy Conservation Code is mandated through its adoption in the International Building Code. So you'll see that You'll see that as part of the requirements as well on the mandatory side. Switching to the voluntary code requirements, there's a lot of interest in passive house certification from both a residential and a commercial perspective. And continuous installation is one of the 5 key principles of passive house certification, specifically using continuous installation to eliminate thermal bridges. So there's a huge demand for really the best and highest efficiency of walls through passive house certification. So providing an ideal opportunity to use some of the best continuous installation systems on the market. Also looking at LEED certification, both the current version of LEED as well as LEED v5 that's coming out, expected to come out later this year. The single highest category to earn points is in the energy and atmosphere credit. Up to 20 points are available for meeting certain energy performance, energy reduction thresholds through the LEED rating system, providing significant opportunity, especially if you're seeking some of those higher LEED certification rating systems, the platinums, the golds, being able to make a significant impact using continuous installation to reduce the energy demands of those buildings. And I think the last system that we have here is the green globes. There's nothing specifically in green globes that talks about continuous installation. However, there's tremendous opportunity by using effective continuous installation systems to impact many of the areas in the green globes rating system. So this is something else that's absolutely worth keeping an eye on and aiming for some of those voluntary certification systems as well. And at this point, I'm going to turn it back to Jose to talk about a chart, a tool that the team at Advanced Architectural Products has developed. But before doing that, I just want to mention that this is a tool that was entirely developed by the Advanced Architectural Products team. We certainly see opportunities, and we've received a lot of positive feedback on this tool from those throughout the building enclosure market on the value of this tool, but I don't want to imply that it's a consensus-driven document or chart. It's not, but it is a great tool to help in that selection process. So Jose, go for it.
Thank you, Kevin. So there's 6 performance criteria that we'll be evaluating today in terms of comparing the 4 sort of different types of Z-girt systems that you see on screen here. But wanted to just start with identifying and putting each of our Z-girts into a class system of its own. So the 4 really main systems we'll be comparing are your composite metal hybrid systems, which you have on the far left there, your perforated thermal metal Z-girts, which are a largely steel-based product with some sort of thermal break on the back. The third item is fiber reinforced polymer FRP Z-girt. So these entirely use FRP. There is not any steel at all. And then lastly is our legacy traditional entirely steel Z-girt systems. Just by looking at various Z-girt systems on the market, it would appear that they visually look the same and perhaps might even perform the same in some instances. But really, the purpose of this chart is to highlight and differentiate the key performance criteria that we feel designers should be aware of when selecting a Z-girt system. And if you really think about the 6 performance criteria that you see on screen here, it kind of goes in order of building life cycle, if you will. So starting off with structural capacity before anything is installed on the building are the Z-girt systems themselves designed and engineered to meet the demanding loads that may need to be carried on that building. Starting with installation and from a structural performance standpoint, how do all these different materials and bits and pieces work together once they are installed, and how well do they perform up to their intended purpose throughout the life cycle of a building? And then once things are installed, how well are all of those connections keeping and holding their permanence? One thing we'll talk about is the importance of having a steel-to-steel connection. So it's very important to evaluate when choosing a Z-girt system how those connections will be made between the cladding and the girts themselves. Then once everything is installed, these next two are really looking at performance of the building throughout its life cycle. So how well does it manage energy? How well does it perform from a thermal performance standpoint? And then is it able to eliminate thermal bypass? We'll talk a bit about thermal bypass in a little bit here, but that's sort of related to the thermal bridging we talked about. If you can eliminate thermal bridging, which is your number one killer of energy efficiency, you may still have issues with thermal bypass if those aren't addressed as well. And then lastly, if there is any sort of catastrophic event facing the building itself, how well will it withstand and sort of hold its intended structure throughout that event? This here is a full picture of what the class chart looks like here. I encourage you afterwards to go to our website. There is more, there's much more information in sort of white papers, detailed reports behind each of these performance criteria on here. So we do encourage you after the presentation today to go on our website and really explore these different performance criteria and sort of the research and decisions that led to these rankings here. But we'll be walking through each of these systems and the performance criteria here in a minute. Start off with some definitions of the various classes. So class 1 systems are going to be our composite metal hybrid Z-girts, and these are really going to give you the best performance overall from both a structural, a thermal, and a fire safety perspective. So we know class 1 systems have the highest thermal performance. They have the strongest structural capacity. They provide permanent connections while also eliminating thermal bypass and passing NFPA 285. If we move on to class 2 perforated thermal metal Z-girts, these are going to slightly compromise on the structural performance and the thermal efficiencies as well. But similar to class 1 systems, they are going to provide that permanent connection and also the compliance with NFPA 285. And then finally, our class 3 entirely FRP Z-girts. These are going to perform the best from a thermal performance standpoint, but I think as we're all probably aware, we're going to sacrifice a little bit on, or maybe not a little bit, a lot on the structural capacity standpoint with an FRP Z-girt, as well as not allowing for that steel to steel connection that I mentioned a few minutes ago. So our first performance criteria is structural capacity. And again, here we're really talking about before anything is installed, how well is that Z-girt designed and engineered to support and distribute the loads effectively, you know, ranging from heavyweight cladding to various other building materials. And so when we look at our comparison of the different systems, you can start to see where the performance compromises drop off between our three classes here. So our class 1 systems are going to have the highest structural capacity. That's because they combine both crosswise and lengthwise tensile strength in the composite materials combined with steel to really give you that maximum structural capacity. Whereas moving on to a class 2 system, if you remember from that first slide that we had with the 4 types of Z-girts on the market, those class 2 systems have a large amount of steel that's removed in that cross section. Sometimes almost 80% of that steel is being removed in the cross section, and we know that that's going to affect the structural capacity in some way. And then lastly, the class 3 FRP Z-girts, typically they don't have both the crosswise and lengthwise tensile strength. So we know that they can really only retain about 25% of the structural capacity of a traditional steel system. Moving on to structural performance, we've got an image here. This is really trying to illustrate sort of the various extreme conditions that we can sometimes see inside of a wall cavity. So when we're talking about structural performance in Z-girts, we want to make sure that under any circumstance, whether it's an extremely hot or an extremely cold temperature inside that wall cavity. We want to make sure that all of the systems and materials are maintaining their integrity and their intended strength, stability, and functionality throughout these various cycles of weather and temperature. And we can see from the results here that class 3 systems are going to be the ones that you compromise on the structural performance here. And that's because class 1 and class 2 systems, because they do incorporate steel, there's been extensive and tons of studies done at elevated temperatures within that wall cavity that show that steel performs over time. Versus the class 3 FRP systems, there just hasn't been that level of research and testing done at those elevated wall temperatures. And so that's why we can say that you only get temporary structural performance out of a class 3 system. The importance of having a steel to steel connection really can't be overstated enough in this presentation here. And what we have here is an excerpt from the ASCE design guide for FRP composite connection. So this is the American Society of Civil Engineers essentially giving us a result of what they saw when there was improper steel-like connection details. I won't read the full excerpt there, but that last part is pretty important. In this case, careful review of the engineering drawings revealed the fact that the majority of the connection details were improper, and as a result, failure was unavoidable due to the low tensile and low flexural moduli and strengths of the isophalic matrix. So essentially what's that saying is when you put a screw into a piece of FRP, um, you're you're effectively severing those strands and those rovings that are providing that tensile strength. And because of that, ASCE here is saying there will be unavoidable failure at some point when you don't have a steel to steel connection. And so when we look at our comparison of the classes here, again, those class 3 systems are really, really going to compromise on not having those any use of integration of steel in their systems at all. ASCE actually also says when you are screwing, if you're attaching something to a piece of FRP, you need to use sort of a bolted connection, a steel backer plate of some kind. Well, we know that's not only going to make installation more difficult, but it's also going to add to the thermal inefficiency of the building because each of those screws is providing more and more conductive material, which we want to eliminate as much as we can in our building envelope designs. Static thermal performance. So how well do these systems and materials control and maintain their thermal efficiencies over the life cycle of a building? So that image that we have there on the left, bit more colorful in nature, a bit more happening in that photo, but that's actually not a good thing when we're talking thermal efficiencies. That there on the left is an example of an entirely steel Z-girt there, and you can see those colors penetrating darker, lighter, penetrating to the right there. That's thermal bridging. That's thermal bridging happening. That's energy loss as an example right there on screen. Compared to a class 1 system on the right, because it's a composite metal hybrid, you have a composite material where it needs to get that thermal break, but you have the steel engineered where it needs to be as well to give you that permanent fastener connection. And so because of that unique design and engineering of the class 1 systems, you can see on that right image there that those colors are not penetrating and flowing over to the right. So that's eliminating any of that thermal bridging that we had talked about is so necessary with continuous insulation systems. And then looking at our comparison of the systems here, class 1 and class 3 systems are going to give you a very high static thermal performance. Again, that's because they're strategically engineered with composites in the right spaces to give you that thermal performance. Whereas you're going to sacrifice a little bit of thermal performance with the class 2 system. Again, those are largely steel-based systems, so very conductive, as well as not being able to eliminate thermal bypass, which we'll talk about in a bit here as well. That also leads to a decrease in thermal performance. Speaking of thermal bypass, this is the unintended movement of energy through gaps, cracks, or voids in a building's wall. So if we think back to one of those first slides about thermal bridging, um, you may choose a design that completely eliminates that thermal bridging. However, you may still run into issues with thermal bypass once that system is installed. So the image in the middle there, that's an example of a class 2 system, class 2 or class 3 system it's just not engineered in a way to eliminate thermal bypass. You can see it's not airtight on the left or the right of that insulation in the middle there, and that's allowing space for that unintended energy movement throughout that wall system there. The image on the far right, again, could be a class 2 or a class 3 system, but this is showing an example of either improper installation or because the engineering and design of those Z-girts doesn't have that airtight fit around the insulation. There could be sagging or moving over time of those pieces of insulation. Again, all of this is leaving voids and cracks open for energy movement. Compared to the image we have on the left there of a class 1 system, you can see the Z-girts are designed to the exact specifications of the insulation in the girt there, so you don't have any space on either side of your insulation, as well as that 3-point compression seal that you see in the middle there. That's something called a thermalock, and that's really going to give you that extra sense of security knowing that you have a 3-point compression seal around all edges of your insulation. And looking at our class comparisons, class 1 systems really are the only ones on the market currently that can totally eliminate thermal bypass. As the example showed on the previous slide, the class 2 and class 3 systems just aren't engineered and designed in a way that completely eliminates that thermal bypass, therefore sacrificing not only thermal efficiency, but thermal bypass as well. And then lastly, we have NFPA 285. So this is how well do these various Z-girt systems perform in the event of a fire. And really the thing to point out here is that NFPA 285 is a test of the entire wall assembly. So if you change one minor component or piece of material in that wall system, that essentially you need to run an entirely new NFPA 285 test. And with the class 3 systems, we see those are compromising in some performance there on NFPA 285 just because they don't have that legacy testing that's been tried and proven over time in a number of various wall conditions. There's been very limited testing in a very limited number of wall conditions for class 3 products that means we can only say it has moderate compliance with NFPA 285. So in summary, our chart here is really a tool to help you as designers or specifiers or contractors to just be more familiar with the Z-girts that you're either selecting or installing and really give you a better sense of where the performance compromises might be that you're making in choosing a class 1, 2, or 3 product. Um, if you want a system that you don't have to worry about making any performance compromises, class 1 is your way to go. If for some reason there is performance compromises that can be made with your project, again, a class 2 or a class 3 system may make sense, but it's important to know where those performance compromises will be made. And you can do that by, again, going to greengirt.com. There's an interactive version of this chart on the website, tons of more research and information behind each of these 6 performance criteria on there. Some other things to keep in mind when selecting a Z-girt system: ease of installation. The more we can save on installation time and make it easier, the better things will be, both for the contractor, for the owner, and the entire team. Think about the sustainability side of things, whether, how materials are sourced and if that's sustainable. And once they're installed on the building, how does that perform from a sustainability perspective over time? Things like building health, where products were they made in the USA? And then lastly, what kinds of engineering support do these systems come with themselves? Just wanted to talk a bit about taking a systems approach. I've talked a lot about building envelopes, building enclosures, continuous insulation, and how all of these systems and materials work together to get you a maximum structural and thermal performance. And so it's important to select systems that are designed and engineered to work together, um, and really avoid any patchwork type solutions. I would recommend you want to try to avoid using products from individual manufacturers, and really try to choose systems from one manufacturer that can accomplish many different things. With that, I will turn it over to Kevin.
Great. Thanks, Jose. And this we're a little ahead of schedule. This wraps up the official educational portion of the presentation, looking to talk a little bit more about advanced architectural products systems that we manufacture, and how those align with the classification chart that Jose was talking about. Want to start off by saying, as you see on the left, those class 1 systems. For the past 14 years since Advanced Architectural Products has been manufacturing, we've exclusively manufactured composite metal hybrid systems, those class 1 systems that sort of combine the thermal performance of fiberglass products with the structural integrity of steel-based products. And we've been manufacturing those, almost 4,000 projects throughout the US and Canada to date. Super excited though, just last week in New York City at the New York Build Expo, we formally launched our first ever Class 2 product. We'll get into a little bit more detail about the green girt steel and how it's the best steel girt on the market today. But just wanted to call out these two different classes of products that we manufacture. We'll spend some time first talking about our composite metal hybrid systems. As you can see on the next slide, this is what composite metal hybrid consists of. You can see that illustration on the left. There's a lot that goes into it. Imagine hundreds of glass rovings, both going lengthwise and perpendicular, in the composite metal hybrid, as well as continuous filament mats. So you get that structural integrity in all directions, impregnated with resins and reinforced with steel in 2 locations. You can see in the image on the lower right how that all comes together to form the composite metal hybrid systems that we're known most for. So looking at the, I guess, the material composition aside, this is how it's made, how it's manufactured. And then, like I was saying, imagine hundreds of spools of glass rovings being pulled through a filament mat that allows them to form that classic Z shape, impregnated with resins, all bio-based and red list free, formed even more tightly into that Z shape, and then heated in a die, pulled through, that's the pultrusion process, cut off into the lengths needed, and then reinforced with those metal inserts, so you get the composite metal hybrid products. Our most popular, the green girt CMH. These are sort of the first and some of the strongest products that we manufacture. Green girt Max, which is 0.20 inch thick steel reinforced flanges, is our highest strength system, manufactured in 8-foot girts, as well as the green girt Optima composite metal hybrid, slightly thinner reinforced flanges of 0.17 inches. Perfect for some of those lower weight cladding applications, or if you're looking at different spacing on the girt system, being able to provide a lower cost alternative to best suit the specific performance requirements of a building. Both of those come in the standard 8-foot length, whereas the next couple systems, the Green-girt clips and the Green-girt Delta adjustable, are clip systems that are manufactured in 6-inch sections. Again, both of them having the steel reinforcement. The clip is the standard clip that's non-adjustable, where the Delta is adjustable, specifically developed for retrofit buildings, although we've seen it used on many new construction projects as well. Great thing about the Delta adjustable is you can see those dual grips on the right side of the bottom, holding that aluminum L in place and having a degree of adjustability, up to 10.5 inches of adjustability with our maximum systems as well, that allows you to accommodate any buildings that may have already been constructed where the walls aren't completely plumb. You can accommodate for that variance and ultimately have the cladding that's outboard be installed so it's perfectly flush, perfectly level. So those are our wall systems. We currently manufacture systems. I saw there was a question about foundations and slabs. That's something that we currently manufacture. Whereas those 4 products, those 4 systems that I mentioned are all for walls. We also have our Green-girt CMH XO system, which was launched in mid-2024. It's our window framing and window support system. So leveraging that same composite metal hybrid technology to provide that thermal performance, but also the metal components there, allowing the windows to be pushed outboard a bit, supported by that structural steel, that's steel or aluminum in the sill of the window plate that allows the window to be supported, so that you can essentially align the thermal plane of the window with the thermal plane of the insulation, so you get that maximum thermal efficiency there. This is a sort of groundbreaking product that allows you to double the energy efficiency of the window surround from 47%, which when using legacy materials like steel or wood, to over 95% when using the Green-girt CMH XO system. And then finally, Green-girt CMH roof. When you're looking to have that continuous insulation, those R30 values that we saw earlier in the presentation on the roof, we have the Green-girt CMH roof system to help accommodate that as well. Jose was talking earlier about thermal bypass, and that's one of the many benefits that come from the Smart CI building enclosure system. You can see from these 2 sample installations on the right, both Smart CI on closed framing and on open framing leverage the same Green-girt CMH girts, those same Z-girts with fiberglass and metal reinforcement. But like Jose was mentioning earlier, it includes custom routed rigid board insulation from any of your favorite insulation manufacturers. We do all the routing and profiling in our warehouse so that those insulation panels arrive on the job site, ready to be installed and fitting the exact specifications of those Z-girts. So you get those dual 3-point compression seals on the top and bottom of the insulation. We provide pressure seals as well to be inserted between adjacent insulation panels. So there's absolutely no unintended air movement. There's no air movement at all going through the Smart CI system. So you get that full air and watertight enclosure system. A couple different ways it can be installed. Additional details on our website. We're happy to talk more about that as well. Here is a better version of that Green-girt CMH XO system. You can see in this one, the lower circular insert at the bottom, those aluminum dead load clips are what allow the window to be pushed outboard, so that you get that alignment with the insulation plane, which is where you get that maximum energy efficiency, and the structural integrity of being able to support the weight of that window. And as I mentioned, this is our newest product announced just 7 days ago. This is Green-girt Steel, our new continuous installation system that's entirely steel-based. Fantastic for many different levels, many different reasons. First of all, being the highest strength Class 2 product on the market today, 20 to 50% stronger than some of the other Class 2 steel-based systems. Also, the highest thermally efficient steel-based system on the market, from both Class 2 and the standard steel Z-girts. Thermal efficiencies well into the 90% for some of the different configurations. So knowing that when you use green girt steel, you will be getting the best, most thermally efficient steel-based system on the market today. Also, you can see in this image here, it has a simple overlapping design, which makes it much easier from an installation perspective. You can see the integrated insulation retention locks flipped upward on that horizontal axis, allowing the girt itself to hold the insulation in place, eliminating the need for the thousands of stick pins or other fasteners to hold insulation. With the locks, as well as the overlapping design, doubling the speed of installation. So being able to install green girt steel twice as quickly as other steel-based systems on the market today. And the final thing I want to mention about the green girt steel is it is engineered for thermal expansion and contraction. So with other systems, you may need to leave up to a 1/4-inch gap between girt systems. This can be installed simply overlapping, which makes the installation process much, much easier as well. And like Jose was mentioning earlier when talking about the systems approach, one of the things that we're most proud of at Advanced Architectural Products is we're not just selling a product. We have a whole family of accessories, a whole family of systems that are engineered to work together. So you can buy everything you need from your continuous installation or cladding attachment from us in a way that everything is engineered to work together. You can see some samples of the accessories that we have available here, many more on our website as well. And another one of the differentiating benefits that we provide to customers who use our products is a full breadth of engineering support. So whether you're looking for help with product selection, details or specifications, spacing, application, service temperature, we have a full engineering team that's available at no cost to support any of the engineering needs that you would require for your project. We also take a lot of pride in the fact that we conduct a finite element analysis for every single project, ensuring that the structural and the performance goals that you're intending for your project are actually realized through the design. And like I said, all of these are provided at no additional cost and help just ensure the structural integrity and the performance requirements that you're hoping to get from your project. And before turning it over to Jose, I'll just mention that we have been installed green girt CMH, green girt steel, smart CI, and nearly 4,000 projects throughout the US and Canada. Jose will go into a couple examples of some of those different projects.
Thank you, Kevin. Yeah, we've talked a lot about Z-girts and building envelopes today, so we'll just take a couple minutes here and show you some examples of A2P's Z-girts and continuous installation in practice here. First up, we have the San Francisco International Airport. This is using 100,000 square feet of the green girt CMH system with mineral wool. Again, you'll see a lot of mineral wool projects here, but we are compatible with any type of installation. Here we have a mixed use project in Georgia. This is also using the green girt CMH system with mineral wool. 59,000 square feet was the size of this project. This here is a photo of the green girt CMH clip system in action. This is an education project in Washington using 1,700 green girt CMH clips. The other images we saw were horizontal installations of green girt. This here is a vertical installation using mineral wool. This is on an education building in Chicago. Again, this is using the green girt CMH system at 40,000 square feet of space. And we have another mixed use building, this one here in Michigan, using 60,000 square feet of the green girt CMH system with mineral wool. with terracotta cladding. I think most of the other examples we've seen have been ACM or metal panels, but again, compatible with any type of insulation and any type of cladding. This is a newer project. This was actually one of the first projects to use both the Green-girt, or I'm sorry, both the Smart CI and the Green-girt XO product. So here we have the Indiana Law Enforcement Academy using 60,000 square feet of the XO around the window framing that you see there, and then also using the Smart CI building enclosure system. You can see that rigid board insulation there, a bit different from the mineral wool that we've saw on the other slides. This is a healthcare facility in Dallas. Again, this is an example of another horizontal installation with mineral wool. This is using 16,000 square feet of Green-girt CMH. And another healthcare facility in Montana. This is using the Smart CI on open framing with 44,000 square feet of project here using the polyiso rigid board installation. Again, all custom routed to the exact specifications of the girt in our manufacturing facility in Michigan. This is an interesting example. You'll see there's tons of different cladding that's used. I think there's 7 different types used on this building here. This is a hospitality project in Massachusetts. Again, using the Smart CI on open framing system for 177,000 square feet. Great example of the variety of cladding that A2P systems are compatible with. And here we have another healthcare facility using the Green-girt CMH system with mineral wool. This is 7,500 square feet in Illinois. I think this is the last one. This here is showing the Delta adjustable system here with mineral wool. This is on a healthcare facility in Massachusetts using nearly 37,000 square feet of the Delta adjustable system. As Kevin was mentioning, we've been installed on nearly 4,000 projects across the US and Canada. Showed you a couple there, but there's tons more examples on our website, greengirt.com. You can filter by location, project type, system type, etc. So again, we encourage you to head to greengirt.com and check out our portfolio of projects. Got a QR code on screen here if you're interested in visiting that class chart page on our website. Again, there is tons, it's interactive on the website version. Again, links to all of the research and data that went into the ranking system here available on greengirt.com, as well as that QR code there. As well as tons of more resources on our website, from product information to specifications. We have a technical library. There's an energy calculator if you're looking to plug in sort of some general parameters of your project and get a number that can show you the energy savings you'll have from using a Green-girt or Smart CI system. Again, hundreds of project examples. We do offer other AIA and CEU courses in addition to this one. So if you're interested in setting one of those up, we'd be happy to schedule something with you. And then again, technical library, tons of white papers, articles, and other research on our website as well. Then lastly, just wanted to mention we are in the process of updating all of our guide specifications. So we're hoping to have those here soon, perhaps the next couple weeks. So we'll certainly follow up with each of you after this once those specs are available. But in the meantime, if you're interested in seeing the current versions of the specs or would like to download them once they're available, again, they will be on greengirt.com. And that concludes our presentation. Kayla, happy to answer any questions or how you would
Yeah,
like to proceed with that.
sounds good. Yeah, thank you for that. So there's just a few questions here so far. So folks, if there's any other questions that you have, now's the time. I'll go ahead and start with this first one. Kevin, I feel like you already kind of answered this, but maybe you can elaborate a little bit further. Do you have any solutions for slab insulation based on IECC requirements, the vertical insulation on the slab to cover the top of the slab?
Looks like you may be having some connection issues.
Yeah,
Um,
he's like very still, so probably frozen. Yeah.
I personally don't have that answer off the top of my head, but I would certainly be happy to connect you with one of our engineers.
Yeah, that's fine. If Kevin is able to rejoin, we can circle back to that question. We do have a few folks asking if they could have a copy of the slides. Jose, is that something you guys are willing to share?
Sure.
Perfect. Yeah, that would be great. So we'll get you the information of the folks that are asking for the slides, so that way you can connect afterwards and share those. We all also will also you have the recording of the session on our website in just a couple of days when it's posted, so you're welcome to reference that there as well.
It looks like Kevin is back as well.
Yep, my apologies.
Hi. I don't know if you what you heard before you dropped off, but we had one question that, as I mentioned before, I think you kind of touched on, but I wanted to make sure that this person, got their full answer. So I'll read it out again. It's, do you have any solutions for slab insulation based on IECC requiring the vertical insulation on the slab to cover the top of the slab?
No, we do not. As of right now, it's just the wall products, the window products, and the roof products from A2P.
Okay, perfect. Thank you. All right, so moving on. How do you decide if you use vertical or horizontal Z-girt installations?
Yeah, and that's a great question as well. And a lot of it depends on the type of cladding that's being used. So you can imagine if you have like a long horizontal piece of fiber cement, you're going to need something vertical for that horizontal cladding to attach to. Similarly, if you're looking to do direct attach, depending on the size, the orientation, the dimensions of any metal panels or other pieces of cladding, you'll want to select the Z-girt orientation that complements that, or have the option of using hat channels on top of the Z-girts. Add an additional step, but it does provide some additional design flexibility. So a lot of the selection process really does depend on the cladding support. And like I said earlier, we do have an engineering team that's available to fully help with any selections or answering any questions or giving any guidance for questions like that.
Amazing. Thank you. All right. So next we have all of the all of the projects you have showcased are very large commercial projects. Can green girt also be used on smaller residential projects? Is there a minimum square foot requirement?
Yeah, I'll go ahead and take that one too, if that's good with you, Jose. And we do find that a lot of our customers are those large commercial or educational medical facilities. We have been used on a number of high-end single-family residential projects, many multifamily residential projects too, but they are usually the larger projects. I'm actually kind of interested to see with sort of the changes on the horizon with the International Residential Code and the potential to include requirements for continuous installation there, sort of what that does to the market over the next several years. But right now, we do see our projects largely used on the commercial type buildings with a limited number of single family luxury residential projects too.
Mhm. Yeah, that makes sense. Perfect. All right, let's see here. Um, all right, a few more people asking for a copy of the slides. Okay, so one more question just came in. Um, they're asking if Cascadius clips are going to fail in the long run.
Um, that would be a great question to ask the team at Cascadia. And I believe the Cascadia product, if I'm recalling correctly, has long fasteners that are used that go directly from the cladding to the substrate. So if I'm recalling that correctly, I think there is that steel to steel connection, even though that spacer or that clip is fiberglass, it still provides that steel to steel connection. Whereas some of the entirely FRP based Z-girts do not have those fasteners that go through the entire product. And those would be the ones that I think the American Society of Civil Engineers really calls out through their composites handbook, that there should be concern over the long-term performance of, because it doesn't have those fasteners that go into that provide that steel to steel connection.
Awesome. All right. Well, that was wonderful. I think that's all of the questions for now, and we are right at time. So, any final notes before we all hop off? Awesome. Well, thank you so much, Jose and Kevin, for a really great and thorough presentation. And thank you to everyone who joined us today. I hope you all have a wonderful day.
Yep. Thank you all for attending. Take care.
Thank you all.
Thank
Have a
you.
good afternoon.